There we go.
And welcome back to crafting.
So anyway, that's where the pile of gold is located, and then.
Welcome back to the Python TIG.
Finish burying the body.
Yeah.
About machine learning. Hi everyone.
Yeah, we can get started, I guess. So it's the I looked this up. It's the 7th TIG on Python and the 3rd meeting on data science specific to Python. So yeah, we've got a very small crowd tonight.
It's because it was a complicated topic and people lose interest over time.
Yeah. So what are we talking about tonight, Chris?
Okay, so we can talk about the chapters and we can talk about the code. I don't think anybody here wrote the code for the exercise yet.
I have not written it yet, although I have started. I have trained and tested, but I have questions about that. But let's.
Yes, I think we may have been incorrect in a little bit of our direction with that, and so we can probably
Good thing we didn't
clarify.
Yeah.
Yes. Okay, so you guys want to go through the book first, or do you want to go over those questions first?
Yeah, maybe, I don't know, jump, whatever you want to do, man. Jump
All right,
in questions.
jump in.
I noticed some people join the stream. For those of you on the live stream, we'll monitor questions. So if you have a question, just post it
Yes, please.
to wherever you're at. If you're on YouTube, I think you can just post it there, and we'll monitor those questions.
So can you print out a few? Yeah, exactly. Okay, so I got it up there, right? This is the poker hand data.
Mm-hmm.
And you've got a 110, 111, 113, 112, 1, 1, which is the highest hand you can get, right? That is a royal flush.
Yes.
Okay.
Which is a 9.
Which is a 9.
Yes.
Yeah.
So let's pull up the data real quick, or the labels of the data, right? Okay, so we have the data folder, which is where we got this, and then poker hand names. This kind of tells us what we have. So these are the column attributes, and then the classifier that we're trying to classify. And this is where we had the misguided information a little bit. It's not going. This system is not going to tell us whether or not we're going to get a better hand or anything like that. This data is meant to, as a large data set, to check against, to learn poker hands, and to be able to tell us what poker hand we do have.
Which is interesting because
you share your screen.
You can also
right.
Hangout.
John
pointed that out. Click the no, not that, on the left. Close that. On the left hand side of the second one. Yeah, that guy. And that entire screen, I think, is the first.
So yeah, what's interesting is this data set in particular, you can definitively write rules. So this is something that Brad and I were talking about at the net, or was it ArchSig? We were talking about ArchSig where there are certain instances where a set of rules.
Did you just drop? Sorry, hang on. Fixing the screen. I got you. There. Chris is screwing something up.
What happened?
It crashed.
Oh, I had this problem before. It's Chrome
on Windows or on Mac? No. Chrome and a VM. Do that. I mean, you can't do Hangouts not in Chrome. This has worked before for you.
Yeah. Okay. So hold on. Don't click the share screen yet.
Everyone.
Or if you click share screen, then click something other than entire screen. Try that.
There you go.
Yes,
yeah.
that's
Sorry,
working.
everybody. Technical difficulties. It should come up in a second.
Well, I have to go back and share my screen every time now, right?
No.
Oh, there's your video.
That's it. So.
No. I mean, like we're looking.
Yeah, he doesn't.
Because I want to show the browser, and I want to
go back.
show.
Try entire screen one more time. Just give it a. Okay. Yeah, it crashes every time. Do it in IE. I don't think you can. Hangouts doesn't work in anything but Chrome. I'm pretty sure. Yeah. Cognito mode is not a bad idea. we're working on it. It's bouncing all over the place. Every time he joins, his camera turns on, so it's him joining and crashing and joining and crashing. No, they can still hear you on the live stream right now. They just can't see you because I'm still logged in. So, and we are broadcasting. So. I wonder if I can make you share your screen or something. Oh, that's true. Maybe audio's dropping. Oh, it's picking up audio on my machine. It must be picking up my audio. Holy crap, man. Google for now, since we're doing most of that. And when we switch to the code, we can update Chrome.
In Soviet Russia, Chrome updates you.
Yep. Google Hangout. Is this going to get me Chrome entirely? All right.
Can you see the screen?
Yeah, I see you bouncing around over there.
All right, sweet.
Sweet. Okay, we're back.
And we're back.
So yes, this tells you, and what's interesting, this will tell you what, this will basically learn to calculate what type of hand you have, but you can also write a set of rules that calculate what type of hand you have.
Yes.
A more interesting machine learning problem, I think, would be how to determine what to bet, knowing the cards that are up and your hand. That's what we thought. Yeah.
But I mean that more plays into artificial intelligence, not machine learning. Because machine learning, you're trying to learn the data and not necessarily min-max outcomes and those things.
But you can bet on a probability, right?
Yeah, you can.
Yeah. So it's not a categorization problem. It's a
Regression.
regression. Yeah. Yeah. You need to guess what they have. So based on what's showing. And what you know you have. And what you know you have. Yeah, if you're playing Hold'em, if you're playing Texas Hold'em, you know what's on the table, you have.
You have two cards, there are 5 on the table. What are the odds you're going to
Exactly. Yeah. And so that's how a poker player's going to play anyways. That's the odds, right? So you just if you can pull like a 70% right, I'll go play Vegas with those odds. Yeah, exactly. I'll be killing it at the table.
Yeah, but isn't that already still a finite set of rules? Like, doesn't the Poker Channel show that when
they have an algorithm that does it? Yeah, if you're. I'm not going to say that I've sat and watched poker before, but I've heard people who sit and watch poker. They show you, they have a camera under the cards, you can see what the person has, and they know what's on the table, and they instantly calculate the percentage of them going to win. You know, the next card that's going to be dealt, who's going to win that hand. Right. So it is a solvable problem. Agreed.
Yeah.
But they also do it in conjunction with knowing what the other person has.
Right. That's true. That's true. They know more data than we would.
So they have more data than you would normally have.
Right.
Because they're watching everybody's hand.
Right. And so what would be interesting as a machine learning exercise is if you do not have that data. Right. And just based on, what's showing, what should you bet and what's the outcome of you winning, et cetera. So this data set is telling you what the probability. No, this is the challenge. This is like learning the hand.
The challenge there, though, is you have to decide how much you would bet. So 70% odds sound great until you think about, well, somebody goes all in. Do you still want to go?
Right.
Do you want to put all your money on the table?
Yeah. So another feature is what the people before you have bet. Yeah. Right. Like that's another column. Weights your algorithm, right? It weights your risk column. And so then there's
how much money? What percentage of my
it weight your risk tolerance, right? Where on the
See, it all goes back to World War II.
Yeah, where? Is it a tank or not a tank? That's really what it goes back to. But yeah, where on the curve do you land?
Yeah, I mean, again, it's more of a statistics problem than a machine learning problem. Like you can.
So at that point, it's less interesting to me, but I mean, I'll still obviously go along if everybody is.
Well, no, I mean, I was under that understanding too, and so I think when we were talking last time, we were just trying to pick as a group what we were going to do, and I think we just picked the wrong thing.
Yeah.
One thing I realized was that March Madness just now. And so there's a big competition every year.
Basketball.
Okay. No, a real competition.
Oh.
I see. So Kaggle, the home of data science, right? So they actually put on like a $15,000 prize for predicting brackets and things like that. And then lots of people actually have other different competitions out there. So one thing that we could have done is do, it's $25,000 prize actually. So it's increased since I last looked at it. So
you know what's funny?
Yeah.
My dad goes every year to Vegas during this time to bet on these games.
And how does he do?
He always takes some money. I've
A
never
dollar or like money?
No. It's always enough to at least pay for his trip out there. And sometimes he has a lot left over, sometimes he has a little left over.
That's not bad. A free trip and free booze the entire time you're there. That's a good deal.
Yeah.
So one really cool thing that they have is they have data for the kind of beginning of the season sort of thing. So
Right.
one thing that could be done is we could create a predictor, and then you could go to Vegas and start predicting, start betting on things.
Wow. Madness is going to be over shortly. Isn't it?
Yeah. So that's the
Madness has a limited time frame.
yes.
But here,
But you could prepare
that-
for next year.
is that data that they're uploading up to date? So it'd be interesting to take the first set of data for the first round, I think you said you had, and predict. And I think the second round's probably you already know.
Yeah.
So it'd be interesting to run your predictor and see how close you got, right?
Yeah.
I also feel like this is one of those things, right, where it's like the interesting aspect of sport is its unpredictableness. So like I know that there was a huge upset in the first round of March Madness, like, and that always happens, right? Some teams, there's no way they should have won, and like your algorithm would never pick them. Right?
So, but what if you started incorporating the Twitter data of all the basketball players, and you knew that they were having a bad day, like, oh, they got arrested for drunk driving the day before, and they go to
they're
play.
not playing.
But maybe you can find something out about their personal lives to figure out that they're going to have a diminished game, and then play that in. So it's like it's not totally unpredictable. It's just that how much of the world have you modeled to make the prediction, right? So you eventually could grow your data to predict upsets, but it'd be a matter of really having some strong data collection. When you talk about smart cities, you can try to potentially having cameras in the street lamps, then maybe you could figure out where they all were last night and be like, oh, they're gonna have a good game anytime they go and eat at Pueblo's Mexican food, the day before, they get some pretty.
That's pretty intense. I did facial recognition on this guy and spotted him eating a California burrito in favor of his team.
Well, I would say actually in not favor of his team, if he had a California burrito the night before the game.
Playing a little sluggish. Yeah, so
choose your sitting location of choice.
So that would be an option. But anyway, we can look over the code and figure out kind of what I did. I'm actually having a problem with it in the sense that
you're trying to solve this one?
Not this one, but the poker hands.
Oh.
So basically, back over here, they have the number of occurrences that show up in the data, right? And so like we only have 480 royal flushes here, and so predicting predicting things like that's a little bit hard. And so were you able?
Here we're trying to categorize, right?
Yep.
Yeah.
We're classifying. And so, but we are taking unseen occurrences. It's like, given what you know about what you saw in the data. So imagine you never played poker before.
Right. But I thought that the training data had at least one instance of all. No, because it's just ordered, right? Is that what it is? Or
no, it wasn't. So when I looked at it, so that was what was weird about it. I went into the folder here. And we have testing, and then we have training true.
Yeah, training is like 600
so,
basically.
Yeah, and then the testing data is 23 megs. So this actually takes a really long time to run. So But one thing that we didn't do,
Oh, now you're gonna have to try to switch.
yeah, I'll have to switch over. But kind of what I want to get at is like you have, you know, 5 occurrences of the royal flushes, right?
Yeah, that's what I thought. And they're guaranteed, oh, I guess, yeah. If you're running this entire set, the training data, there is at least one instance of all of the hands.
So, but if you've never seen poker before, then you could argue that you're not seeing an instance of something.
So yes, we could write down all the rules to classify these, but like I guess the thing is, without the rules, can you still figure out which ones are the good hands?
Yeah.
Which ones are the good hands?
Well,
Strong
which
hands.
one are not even the strong?
Not even what's good. What kind
what
of hand
is
is
the
it?
hand?
What is the
It's
strength
like
of the
guessing
hand?
the iris, right? That was
So,
an advanced
yeah.
version of guessing which
But I
iris
mean,
would-
you think about so
Right.
Well, what you're trying to guess though is, given that you have 2 known cards and there are 5 shared cards, will 2 unknown cards beat or lose to the 2 cards you have known? When you mix,
it's not even the
those
beat or
7
lose.
cards.
It's
Yeah,
just
no, it's not doing that, though,
this
right?
is
it's
not
just to
this.
say.
Oh, that's what I'm saying. That's what you're trying to do though.
Well, all we're trying to do is just say
Which
0 through
here's
9.
5 cards.
Yeah.
What hand is this?
Yes, that's what we're trying
That's
to
all
do
we
right
can
now.
do with
That's
it.
all we can do with this
Yeah.
data right now.
And so we don't know the rules of poker. We just have seen data and so we're classifying.
Yeah.
Our
This-
friend has told us that this is a,
Strong hand.
this is a strong hand, this is a weak hand. So here's a hand,
So
is it strong or weak?
And now if you had examples of
One
played
and
games and you had the cards from both games, then you can create a data set that it could learn off of to figure out what the rules are.
Right,
But
but
right now, all we're just trying to do is say, okay, well, you've never seen poker before. You don't even know what a card really is, right? And so we're going to tell you that we're going to have 9 columns, and in those columns are going to be this
9
information.
categories or whatever, 9 types. of
Nine
cards.
types, but the feature set is going to be the suit of the card and the rank of the card, suit and rank all the way down. So you have 10 features, and then the 11th column is the classifier. And so from there, you need to figure out, you know, what is 1 pair, what is 2 pairs, what is 3 of a kind, and so on.
So I mean, this is a very similar problem to guessing the iris, right? Just on an expanded data set. 'Cause
Yeah.
There
Yes.
I didn't know shit about irises. It
On
was
a
just which
restricted data set. It's less complicated than the iris.
but there's more features.
No, I think, well,
There's more features and more possible.
yeah.
outcomes.
No,
The iris
this is-
was one of 3.
Well, the iris is more.
No, because this is discrete data and that was continuous data.
Yes, but I mean, they're just different problems in that way. I don't know if it's a harder or less difficult problem. So in the iris data, you're able to detect the signals very easily, and even though they're not very human readable, this problem, it's more human readable than computer readable. So like the 1 pair versus the 2 pairs, and figuring out what to classify them, they probably have a very close relationship to each other. So.
But you said you had problems with this.
I know why now, actually, from reading this. So what happened is I didn't use the training and the testing sets. I actually split the training setup to learn. Yeah, so I was improperly
You
learning
should
data.
use the entire.
So the problem is when I loaded the 23 meg data set in here and started running it through something, it was unhappy. Yeah.
Really? Only with 23 megs? That's insane.
Yeah. So it was just.
Well,
taking a
were you
long time.
trying to load it all, or were you trying to stream it through? You know what I mean?
Yeah, I was loading it all. So I think that was kind of.
So I think if you stream it through, that'd be better.
So it just takes a little while, but I can kind of show you what I know what we need to change now. We could just
let's check it out. Maybe walk through
program on it.
You guys switch your screen share.
So I took the code that we had on GitHub and I just expanded on it. So I didn't do much else. So I need to switch my screen here. Should I try again? No.
Sure, why not?
No, there's no point. We tried it at least twice. That would be the definition of insanity. Twice is dealing with computers. More than twice is dealing with insanity.
What is that?
The big problem right now is that I don't actually see my IDE in the list of selectable items. So.
Sorry, we crashed again. Give us another minute. We have 6 dedicated viewers that, now we only have 5. Yeah. Oh, there's Chrissy.
Not there.
So what is SDTIG examples? What is that? Is that a browser page? What's that?
Windows Explorer. It's the file location.
Is it cool? All the ones that are maximized, or what causes?
I don't know. You guys can look at my face while I do this.
Apologize, it doesn't live stream. You can watch Chris's face.
That's
You can
weird.
share Hangouts. That'll give you that cool recursive
Right.
thing.
Is there a? Yeah, I say maybe close the browser and try and would build there. I think it's maybe because it was shared once. It's getting confused.
I already closed the browser died. I opened it again. Why don't we go?
Chat, sorry. Rebooting. Give us some time. I don't even know what microphone they're hearing it from too, so who knows if you can even hear me. Anybody? Can you hear me? Can you still hear us? Chris is rebooting. Bachelor, you're the only one chatting. Give me a thumbs up. They're probably behind, so they can't hear us. Yeah, well, they may be dead. All according to plan. Yeah. So this is the best TIG we've ever done. Oh God, what theme color is that? I don't even know what that is. No, it's baby poop. You choose as your background. They choose the color. Yeah. What's on your background? Is it a turd? Little low. Yep, you're really low. Well, okay. Well, Chris is restarting. I'm really low probably because this microphone maybe. Did they play sports in that movie? I wouldn't watch it unless they play sports.
They did. And I think there was like a snitch and like some people on broomsticks. What is happening right now?
Well, just try. Again.
Wait, it's
You
not
don't have
launched.
anything
It's not
started.
You
launched.
haven't launched the development.
Yeah,
Cancel.
Start PyCharm.
Cancel.
No.
Yes. We're back.
Now minimize before you get infinite.
Now start PyCharm and crash it.
All right. Yeah.
Did you,
Oh, you know,
did you update to the new version of PyCharm?
I wonder if it was because you had turned your camera off and then shared, because that time you shared with your camera on.
That's
Share
true.
camera on
That's true.
and then- okay.
All right, we are back. Hopefully the audio is better now.
Hello, everyone.
Oh,
Welcome back.
Hey.
Hang on.
I'm totally even in the wrong project. That's awesome. Something was really funny.
Video and audio is back. Great. Thank you, Russia.
All right, so we can see stuff,
Yeah.
and we're all good. All right,
Yeah,
great.
Got it. Looks solid.
All right, so let me just walk through it. So I didn't change very much. So
So sorry, this is pulled from GitHub, which is what we were working on last month, basically. That's
yeah,
something we've been
let me show that real quick. So on GitHub, I should have a way to see my stuff,
Yeah, apps, you do.
your profile.
Yeah.
Yes. Okay. SDTIG. So github.com/deadlyapps, SDTIG, March Machine Learning. And it's in here. And so I haven't uploaded what I currently have yet because we were doing a competition and I didn't want to like spill anything.
Yeah, exactly.
So, but
How deadly is it? Is what I must ask.
yeah, it's pretty deadly.
It's deadly.
As deadly as that pizza you're eating right now.
These are
So-
banana peppers, not bell peppers. Don't worry.
Oh, okay. Well, yeah, yeah. Thank you. Okay, so I took this initial code that we had here, and then I just added, instead of dealing with the iris.txt, I took the data set from online, the poker data set, and threw it in there. And so then we got the shape out, and this is what was the problem initially, is I threw in only the training data.
Are you using 2 or 3? Are you using Python 2 or Python? I'm sorry.
I always write as if I'm in 3.
3.x.
I'm using 3. These
Using
3
Okay,
for this.
good. And then
Good, yes. Because otherwise I would have yelled at you.
second question is, when I built, I got a warning around the metrics. Are
Yeah.
you getting that same warning?
Deprecation warning?
Yes, deprecation.
Yeah,
I mean, the library's moved on, so it's since.
So I didn't even understand the warning though. It looked like it was telling me to do what I have already done. It said like,
We'll run it. We'll see
hey,
it.
warning, you should
gonna take a long
you should
time.
from Skylearn metrics import metrics. I'm like, what the flip?
That one.
No, well, it's saying that thing is deprecated, so that's all. They just called warnings out.
Yeah, but look at that. Please import from sklearn metrics.
Not sklearn metrics, not metrics. What?
What?
So let's
From sklearn.metrics. So you just
yeah,
say,
but import
Then you put
metrics.
metrics again.
okay,
So we'd
So you just
eliminate
flattened it.
this, and then is that going to give us the right
Yeah, they
thing?
just flattened it.
They flat, yeah. It was in one too many subdirectories. Make sense?
I told you exactly what they wanted you to do.
I have 2 of these running now, so these get pretty long running. So I killed them both.
So you downloaded the data in their data files locally, right?
Yes, both data is locally, but you could do what the book does and just download, like tell it to get it online. So the book typically does that.
Straight 25 megs down.
Yeah,
yeah,
standard
no
25
worries
percent.
there. That'll work every time.
So I have an idea of how to fix this code, but I guess I'll show you what the problem, we'll walk through the code once, and we'll talk about what we're doing. So first of all, one thing that we did is we took so this is just like last time, we're taking 66% of the data and dropping it into the training set, and then 2/3 or 1/3 of the data and putting it into the test set. And so what we'll do differently now is instead just get 2 different data sets from 2 different files and do them. Then
So I'm guessing from this that gen from text loads all of the data into memory.
yes, it loads it all into a NumPy array.
Yeah,
And so
5 megabyte NumPy.
yeah.
Yeah.
That's going to be the issue.
yeah,
And so
and
for the testing, I mean, that's fine for the training data, that's no problem, but for the testing data where it is 23 meg or 25 meg or whatever, we're gonna have to do something.
well, so one option is just to do stratified sampling and then test against the stratified sampled data. So that's like one way to go. Another way to go is just to, I don't know, try it, but also parallelize it across all the processors. So there's
But, I
a
mean, if
great
you just stream it
I
Python.
guarantee you Hangouts will crash.
Yeah. So anyway, let's go on. So I then print out the shapes just for fun. Then I have the last feature index, which is the 10th feature on here. Or actually, sorry, it's the 11th feature, but the
Zero-based.
10th index, zero-based index. So then the training input, we get everything up until the last feature, and then for the training output, we get the column at the last feature. And we did this also with the iris data set, and then the same thing for the test in, test out. Then I tried the SVC, I tried the gradient boosting classifier, random forests. I think random forests work really fast, so I'm gonna go with that for now. And we can kind of see the problem go through right away with the 600 megs of data. We fit the data, so this is the train sort of thing, like we were talking about before, and kind of learning the training data. And then we have the train input, and we're predicting on the test input. And then we find the ROC curve. We can get the AUC. That's interesting. So it's even ReSharper thinks that, or not ReSharper, but PyCharm thinks that we should import that name again, but it ran properly. So that's weird. Then I'm doing, so I haven't really talked about confusion matrices yet, but they talk about them in the book. And so I decided to go ahead and throw in a confusion matrix to make it a visual thing so we can kind of see what's going on. So I'll,
Confusion matrix.
yeah, so do you guys remember what
Those are the
confusion
ones that are on like page 83 and
No,
80. No.
no, they look like boxes on a chart.
Yeah, so we copied some code for the confusion matrix off of sklearn's website and dropped it in here. And then, so I think we could just work on the code together and that'd be pretty fun to do.
What does it do right now?
So, all right, so I'm running it right now. Metrics is not defined, so apparently didn't like that. Oh, well.
Right. Which is interesting.
Even though it's deprecated.
Yeah, I think something's weird with what it understands I have. So that run really fast. So what's happening here? Basically, I only had data for 2 of the classes, and it should have all 10 available things in there. So basically, we just see. So the darker colors are the more occurrences. The diagonal is correctly identified things. So like 0, 0, that meant that it was a true positive for that area.
2 on there. I can't even see them on live stream either. Is there something underneath the blue? Is there like a light blue under there?
Yes.
Okay.
There are different colors here. There are 4 different colors here.
4 boxes. Oh,
And then actually there's a bunch of grays as well.
And then there's a bunch of
That's the
gray.
one we can't see.
Yeah.
Okay. That's what I was wondering.
Yeah.
So when you said you only have 2, how do you know there's 2? It's just because there's 2 rows.
Yeah, there's just 2 columns here because this would have a diagonal all the way across, and then we'd be able to see where we're right and where we're wrong. So let's try and fix
And
the
by
code.
right and wrong, you mean we predicted the correct hand.
Yeah, the
We predicted
diagonal-
the final column in the data set, right?
In this graph, the darker that the diagonal boxes are, from the top left to the bottom right, the more accurate you are.
The more accurate.
And then-
accuracy is depending on guessing what that last column is. Yes.
Yeah. And so anything that's outside of the diagonal is what it guessed incorrectly for that. So I would expect for 1 pair and 2 pairs that there would be confusion there. And so that's kind of, it shows the matrix of its confusion. So it says, oh, it'll predict that for that thing. So we mostly correctly predicted nothing in hand.
Nothing. Okay.
Yeah.
And then we sometimes accurately predicted 1 pair. And then we didn't really have any other data. So
I see.
So scroll up. We're in addition to chopping the data into 2/3, 1/3, are we also shuffling the data prior to that or no?
no, I took that out.
Okay. So this may be an inherent skew of the way that the names file, the training data is organized.
That could be, but the overall problem of being able to identify, so the data just doesn't exist in this data set right now. And so that's the problem at the moment. Oops. I'm going to remove the shuffling, and what we need to do is just load both files.
Oh God.
I'm gonna do it.
And so instead of doing this now, we're going to say one's going to be our train, that one's going to be our test. Right.
And then the line, turn line numbers, dude.
Where's that? Where's line numbers in here? Yeah.
Control, oh, I was gonna say control.
No, it's the file options, I think, in Python. It's in the file.
Preferences.
Yeah, but there's
It's
a.
not control key, and then type in that box.
Yeah, there you go.
I'm not seeing it.
What?
Try right
Search
clicking the
and
gutter.
click off. Yeah, you click off, search again, and it took you to the right place.
Or you could just right click in the gutter and say show line numbers.
There you go. Cool. All right, so now on line, scroll up all the way.
You gotta change the file name.
14.
Poker hand
You
training,
need to say
poker hand
testing.
test.
I think it's not with the true. I think it's poker hand test true. Testing. No true.
All right, let's just kick it off. All right, so what do you guys want to talk about while that runs?
So March Madness is this basketball game, and
yeah, it does. There's people pay you money to predict things. It's really cool.
you said you played last year, right?
No, we tried working on it, and
Dude, still shit. I mean,
Dude, YouTube's gonna filter us. Stop doing that.
yes.
still.
That was way too fast, also, because you didn't actually use test.
Yeah, I feel like that was weird. Train and test. Train input,
All right.
train output.
Were you running this on your Raspberry Pi before or something? Is that why it took so long?
I don't know why it took so long before. And it's not.
I mean, 25 meg should be somewhat doable. Did you rename
Seems like you
the
should have more than 20.
training file to testing and they're the same file on disk, and the actual file isn't the file you think it is?
No.
No.
Because look, it says 25,000 and 100,000.
Yeah,
Right?
that's right.
And that is correct.
What the heck?
Let's look at this plot confusion matrix. Maybe it's crap.
It could be since we commented out
No,
three
wait.
inconvenient lines.
This 0.569, that's the area under the curve printed out?
Yep.
Okay, well, that's pretty crap anyway. It's like better, it's like,
Prowl.
it's like a little bit better than a guess. Just a random guess.
Hey, I'd still win more money than if I played poker without it. So.
Okay.
So one thing that we could try is changing the classifier.
SVC is what we were using before.
This is the one that takes forever though, isn't it? SVC.
Takes longer than the random one, yeah.
Maybe random
And
forest
is
was good without the real
SVC a
data.
predicted, penalized linear regression, or is it a ensemble?
Excuse me?
Anyways, you know where you can get some good abalones in this town?
Yeah.
No, they went out of business.
They did?
Yeah, go figure. Fish House Veracruz is not in business anymore. And
That's
the
because
new-
Chris mentioned them.
Yeah, but apparently they had a run on abalones and they went out of business.
Yeah.
But there's a new fish place going in that spot, so I'm gonna ask them when they open how much their abalone costs.
Yeah, sounds good. It was. I complained about the prices, and that's why there was a boycott
Probably what.
because they realized that there was
Probably.
a problem with the abalone.
Well, somebody
prices.
told me that they were called Fish House Veracruz, but they did not produce anything in the Veracruz style. Like somebody said, "Oh, can I have that Veracruz style?" And they said, "No, we don't do that." Wait, what? It's in the name of. No, we don't actually make anything Veracruz style. Memory would be my guess, but
It's. So how do I do logical CPUs on
yeah, so
here
it's
now?
pegging one core.
Yeah.
And then you can,
Logical
logic
processors. Yeah.
processors.
No,
No?
it's evenly pegging all cores
Yes.
to a quarter.
No, that's
Well over a
weird.
quarter. Right. Well over 25% of all your processors. That shouldn't take that long then. Good lord.
It's learning.
How long? Apparently he's a slow learner.
He's doing some serious learning.
How long do you think it takes? We have no idea because you haven't done it on the real data.
Yeah. No, I don't know yet. But we could put something.
It's only 100,000 rows, right?
Yeah, we should have put something in here to say like fitting done, right?
After you run it again, you're screwed or no? Yeah, you should be all right.
It'll run it a second time. So right now that one's not running. So if I run this, so now it should just be eating up more
Oh my
CPU.
God.
You're gonna run. Oh, good God!
Huh.
Now you're at 50% gas. Why run them at the same time just because you can? Just because you don't like your MacBook? And
I hate this.
I love replacing fans on MacBook Pros.
Yeah,
So
it's nearly impossible.
this is, I mean, so my, I was writing my thesis, right? And
The one that Jim has.
yeah, the one that Jim has. He keeps it for me, and then whenever I ask for it, he just brings it. And so it was, so I calculated it out, and it was going to take like 8 months to run. And so with what it was doing currently. So then what I had to do was I was like, okay, well, how do I reduce that? So I'm like, well, I have 8 processors in this computer. I have 2 more on a server at home, and I have a few more over here. So how do I distribute it across all processors? So I was able to do a map reduce sort of scenario using the parallel map reduce and be able to run it on all the processors on all the machines. So this laptop was running for about a month straight. My server and another machine I had, and I got it out to like 15 processors that was all running on at the same time, and reduced it down to about a month, and got
Man, I
the
should
thing.
tell you about this amazing service called AWS.
Yeah, you know how much money I would have paid for that service had I run it there?
I agree, it's far too expensive.
Yeah.
Yeah.
There's another service called Azure. I would like to
Yes.
introduce you to.
So you know how much money I spent? So that's the problem. Like you run machine learning models and you're like, oh, I want to try this out. Oh, here's a $45,000 bill for running compute. Yeah.
But you guessed which poker hand.
Yes, that's
it's
true.
worth it.
I would ask for a student discount.
That's true.
Your solidly hard problems humanity must know. Which poker hand do I have in my hand right now that I'm staring at?
No, so you're
Fitting
wrong.
done.
All right. So it fit faster than I was trying to predict. So I think we should just grab like the first few 100,000 and then run it one more time.
The training? Or
Yeah, so I'm going to stop this run
Yeah.
and I'll just let this one keep going. And so we'll just let that one run until it's done. But one thing we can do here is just say 0 through 500. 1,000? First 1,000. Right, get out of there. And it should, I mean, it'll be really fast, right?
Yeah.
Well, how much was that? Yeah.
it's 100,000. There are 100,000 rows. You're grabbing 100th of it.
At least 10.
There was a
Because when we said fitting done, we've been talking for, I don't know, a minute or something. And this one's still crunching everything, so we'll see how
You
that
sure
goes.
it's 100,000?
Yeah. It was up there. It's like 9999 or something. Yeah.
Yeah, it was 100,000. It told
That
us.
was
And
a
then,
million.
Are we off by 0? We're off by 0. You're right.
1 million.
oh, you're right. It is 1 million.
So now you're taking.
Well, no, now we're taking 1,000. You just said take 1,000.
But we'll be able to see from the confusion matrix what it got out of it, right?
Sure. But it's still fitting the whole data set, or it's taking that long to fit 1,000?
Well, it's also using the support vector classifier, so that might be an issue too.
But it hasn't even got there yet, right? 'Cause it's-
No, not yet. It should say fitting done by the time we get to that point.
Right.
But what's weird, okay, so
Why would it
test
take so
input.
long to fit? It's only fitting over 1,000 rows. Right?
No, it's fitting
Oh, 1,000 plus.
25,000.
It's 25,000, which is the training, and then it comes out and evaluates 1,000.
Got it. Oh, yeah, right.
What's up?
Nothing. I'm not at all like Googling the answer.
Oh, you find somebody who done this before? Who did this before?
Oh, somebody is actually giving parameters to their SPC.
Yes, that's true too.
Parameterize it. Why?
Well, there's a lot of parameters in the SVC. So if you look at your learning models, you can actually go in here. This is all stuff that we can train. So right now it's using a radial basis function kernel, meaning that, So that means it uses, it draws a hypersphere around an area and then says that this is going to be, this hypersphere is going to be classified. Any point on this hyperplane will be classified based off of this hypersphere. So that's kind of what that's doing. And so the idea is that you have, so if you had 2 dimensions, then it would be a circle, right?
This is why there's only 3 of us here tonight.
Yes.
I mean,
Talking about
like, still, it
hyperspheres.
sucks. It's only 5.9.
Yeah, it didn't even see,
What's up, dude?
Well, I'm
like
guessing
something
it's
in the
just
third row.
there's not a
Oh, what's weird is
there's
that
not an
we don't,
even distribution.
Right, you're taking the first 1,000, but you should be taking the first 1,000 every third or something, like, to get a more even pick, right?
oh, they're not in order, are they?
Well, no.
Do
What I'm-
stratified sampling.
Maybe we should do stratified sampling.
Wait,
That's what I'm talking about.
Time out. Time out.
Right.
I feel like this data is like real life data, the ones that you are testing on.
You know what? We did look at it, and that was an interesting. Okay, so UCI, ML, poker, and so here we are.
Here we will be in 10 minutes.
That was the 25 meg one, right? On top of your streaming and your 64% CPU.
All right,
utilization. However many other pains.
Here we will be.
Our internet's fast.
Okay, so these are in order. No, they're not. 9988881004.
Yeah, but I think if you let's look. Can you do? I don't know.
But look how many ones and zeros there are.
Yeah, exactly. I want to do a bar graph kind of the final row, the final column. Jesus.
Yeah, you have a lot of ones and zeros in that first 1,000. Right?
Yeah. Can
Which is why
you
you're guessing
say
those, right?
what the distribution is for that final column on both the training and the testing data?
Yes.
Metrics.
Metrics.
It's all about the metrics.
So far, everyone who's done this problem and blogged about it has gotten horrible results.
Oh, really?
It's a challenge.
Yes.
Well, that's also probably why there are not many papers written on it.
Yeah, it's like used in such and such research, PhD denied.
It's like something that you want to try and do.
Yeah, of course, a top hat kernel density. That's
No. I mean, this is like, I just want to count the fucking shit. I'm not trying to predict it.
Now YouTube's really gonna censor us. Gosh.
Yeah,
I'm not
so
trying to like.
Yeah, just do a group by last column
seriously.
sum.
Yeah,
do it.
it's probably not in scikit-learn that we want to look. We're looking at NumPy.
It's just a straight up array count, right?
Yeah,
Like it's just
NumPy.
the
I wanna
select
do, like-
that thing group by or
Yeah.
whatever. right?
Exactly, that's what I want.
Well, you want the last column,
Last
and then you
column,
want to count the number of
count the
instances.
distinct,
Yeah,
sounds
that's
like a bar
a
chart.
histogram. If you want a bar
Yeah.
chart from it, you need a
Yeah.
histogram.
Yeah, I know, but
That's
I
what I was
don't want
looking
a predictive histogram,
Sorry.
one that it's going to, anything like that. I just want to straight out count the things. And I'm thinking that
I thinking.
I think-
I thinking I need 2 more years.
I'm thinking that it's NumPy. Yes,
NumPy.
that's what I'm talking
NumPy
about.
dot histogram.
Of course
right?
it is. We could have predicted that.
If only we had an algorithm. What is the method you should be calling on NumPy?
All right, so we'll just print that out. Hey, like, did this finish? This one finished.
No,
Still
that's-
Oh, yeah, that was the
that
crappy
was the
one.
quick one.
All right, so should I let the other one run or just?
No, because you're gonna get crap. Well, actually, you shouldn't get crap because you're getting the entire results.
No.
No, because
We'll
you're
get
only,
crap.
yeah, you're gonna get crap because.
Yes,
It's
because
everyone.
the problem is in the training data, there's not that many instances. I think it's in both, but let's just check.
So here we go. So I'm going to say the test output, and we're going to do a histogram of the test output.
Of the last column. That's not good, yeah.
Print np, or is it np? No, I just said histogram
Yeah. np.histogram.
of test output. Hopefully it doesn't ask us for bins.
No.
How's it gonna know what column? for it?
Yeah, you need column. Oh, output. No, you got it.
Yeah,
Alright,
test
so
output
just the
already
last
has
column.
the
Yeah,
last
yeah.
column.
Except now you're gonna have to fit everything for that to come out.
Well,
No.
the description already has.
We're not at the fit yet. So what happened?
Array 508.
What is
No,
that?
That's
It's the array down below, 508.
Yeah, 508, 419.
508 nothings, 0 ones. That's not right. 0 1 pair. 419 2
1,
pairs.
2, 3,
Why is every other 0?
4, 5, 6, 7, 8, 9, 10.
Doesn't make sense.
Oh, because it's half. Look at the array over there. See, those are looking at halves, 1.5, 2. It's looking at discrete values from 1 to 5.
Oh, there is no half values.
Yeah,
It's
there are
all
no half
numbers
value.
only.
So we are going to need to give it 0 to 9. But you can just put a comma range.
That's bins, I think. So you want.
Yeah, I know, but I'm saying bins equals range of 0, comma, yeah.
0, 9.
Yeah.
Yeah.
And how do you get that histogram into that confusion matrix? That's what I want to know, so I can actually see the actual histogram.
There's a way to do it.
Big phone again, or my crazy. So,
You got like 6 processes running at this point.
yeah. All right.
So are you just running over the top of a running process? Is that why it's opening new tabs? If you had let the process finish.
Yeah,
then
yeah.
it would just-
So the JetBrains products do that. So you can always kick off a bunch of instances and then we'll.
Histogram. 508, yeah, so it's super weighted to the one, no pair, one
Look,
pair.
0, 0.
No actual royal flushes. That's not true though.
No,
It's not 1 or 2.
There's
but
4.
I should say 4.
You know.
I mean, I guess that's probably a realistic like a realistic plotting of how.
You're
many
looking at
come
the test output.
It's kind of-
The train output had 4. We don't know how many, and we need a 9 inclusive. We need to say
9.
10.
10. Yep.
And
That
we
was-
should only bump it up to 10,000 instead of just 1,000.
Yeah. We were only looking at a small.
Yes.
portion
In
of
fact, for the histogram, why don't we just move that up to the top and do it for all? Yeah, like right away.
I'm gonna have to slice it again though. Test output and
Right.
Instagram. So we'll just copy this out. Put it up here.
I don't know what they're telling me here. 2.5 million. Doesn't make any sense.
Great, but you are,
Right.
but look, you've got
It's not
0
test
to
output, it's
10,000.
test, right?
No, we want.
Line 14 at the end, you have 0:1,000. Yeah. There you
All right. So that'll be fun.
go. So what I think what is going to happen here is the training data is going to be representative.
What do we get?
There you go. Hugely weighted at nothing
Yep.
and 1 pair and 2 pair and it diminishes as time goes on. But that's probably realistic, right? I mean, how
Yeah.
many royal flushes
That
do
looks
you
about
get
right.
in a million hands?
Right.
15?
Well, in 2.5 million hands, you
Okay,
get
so
4.
the training data.
You want to do the training
if-
data now?
Yeah, I want to look at the training data as well.
I can just pop them both in there. For
So
the
I think
control
that
page.
the issue is, for learning the hands, you should have an even distribution. For testing the hands, you can have whatever distribution you want, right? But for learning, you want to be able to distinguish between these, and you want to be able to like,
Let's look at stratified and sampling.
no, I think what you want is like duplication or something, you know what I mean? Like,
You want to artificially create an even row distribution
yes.
or an even hand
That's
distribution.
stratified sampling.
Okay, stratified sampling. Awesome. That is exactly what I want. Thank you for bringing that up.
Aren't we assuming we don't know what the hands are to start with?
Yes.
Yeah.
So how would we do that?
No, I'm saying
We know what the weight column is. So we know what the last
Test
column is.
Oh, okay.
10?
So
That's interesting.
And where would they have 10 royal flushes in there?
Yeah.
Maybe because they need more training data.
10 row flushes in a million hands.
No, this is
10
training.
to
Yeah.
25,000.
The first one's 25,000. So 10 and 25,000.
So
And then this
15
one's 15
in
and
a
a million. Yes.
Which is probably why you're having so much trouble, because the relation of how often you should see a royal flush is way off.
Train test split with stratified sampling.
Yeah. If you
So which
just tell it,
means-
yeah.
Say that again. How often you
Stratified,
should see
yes.
row flushes off? In
Yeah.
What?
In the training data.
Where do
Right.
I do?
Because they
So
went up
therefore
to a
your
million
algorithm
rows,
is
but only
saying
added
Go
5
down to the
royal
Royal
flushes.
flushes in here.
No. It would matter. On the training data, you're just learning to categorize. So if it comes up 300
So
million
with
times
argument,
out of, 400
You
million,
can
that would be
say,
fine.
comma, stratified
Right?
walk equals
It's
Y.
the,
Okay.
yeah, it's just that you are not learning, because there are only 4 possibilities.
But
Yeah.
there are 4 of them. You should know what it looks like to get a royal
What
flush.
is the
How does that
Train
matter?
underscore tester.
You just haven't seen
Yeah.
it more. You've seen it at least once. You haven't seen it, go right back to the tab.
And then what's the first parameter?
First parameter
Say 15
is going to
times.
be your
It's the same thing 15
arrays.
times, you think you can guess it. Yeah, I don't know. The number of times, the number of occurrences doesn't quite make sense actually.
Doesn't tell us X and Y. Oh,
So wait, explain this to us, machine learning guru.
So
If you've seen a royal flush 10 or 15 times,
10 times.
10 times, how come you can't guess it? Why does the number of occurrences matter in guessing? Once you've seen it and you've confirmed, like you've seen it and you know what the weighting is,
well,
you see it again and again and again. Like
a support vector machine is having trouble dividing the problem space. So do you remember what a support vector machine looks like when it divides up data?
bring up your favorite picture again.
Yeah.
So it hasn't really figured out why it's a 9.
Right. It had okay. It knows that it's a 9, but it hasn't determined all the different features that make it 9.
Right.
Right.
Because it's only seen it 6 times, and
It's just
that
like-
algorithm is
yeah.
not smart enough.
So this one's, well, we're using a radial basis function support vector machine. So this is what it's doing right here. And so,
So we could parameterize the SVC to use a different one and maybe get better results.
yeah, so if you use linear, it'll slice it into, individual sections. And yeah, it could be, well, it's taking, so the X and Y coordinates on this graph are the input features. And then the color is the output, right? And so you're saying that of those in a 9-dimensional space, we're going to make 9-dimensional spheres around the data and then predict a value.
Oh, that's easy to visualize.
And so, yeah, so
Well, let's.
What did you just say?
So let's take it smaller and
No,
let's.
I want to know what a hypersphere is.
So it's the number of dimensions. So you can only realize the hypersphere in an n dimension, like in a 3 dimensions, right? And so the idea of a hypersphere is that it has more dimensions than can be visually displayed. So this is a picture of a hypersphere.
Doesn't make any sense.
And so,
This picture of atmosphere does not make any sense.
well, so I mean, so
We're doing all this to tell whether we have a royal flush or not. Jesus Christ, we can just learn the rules of poker. It'd be so much simpler.
well, I mean, that's kind of the beauty of it, right? Like, so your brain is doing this, and you don't even realize it, right?
All
Like,
goes back to World War II.
it all goes back to,
All goes back to World War II.
and a little bit before that, your brain started doing things like this.
Lord.
So anyway, the idea is that,
Oh, hypertetrahedron.
so like you take a picture of a 3D object, it becomes a 2D object. So
Of course.
So this is a picture of an n-dimensional object that's getting reduced to a 2-dimensional object, right?
Doesn't make any sense.
Yeah. You can only like.
Flatland.
Yeah.
Yeah, flatland, yes.
So
That's
that,
kind of what it's
yeah.
talking about.
Yeah.
The-
That's like.
Imagining the 11th dimension, right?
This one's
Two-dimensional
easier.
creatures trying to imagine what a three-dimensional.
Yeah, yeah, yeah.
A square.
Stratified
Well, that was his
y and n.
I was
So
thinking.
Y is
there
just
was a
an
book.
array and
Flatland.
it's,
Flatland.
iterations and
And what year was the book written?
1906, maybe.
Okay.
Yeah, it's an old one.
There's a great animation on
That's right.
YouTube that explains the 11th dimension. You guys should really
Again.
look at it.
Yeah, it is
Wow.
It's-
Okay.
Although, okay, so back to this.
Stratified.
So we're going to stratified shuffle split.
And the idea behind stratified sampling here is to evenly weight the distribution of the number of hands we've seen. Reduce the evenly pick. So you have like 10, 10, 10, 10, 10 for all.
well,
of
you're
them.
never going to get 10 royal flushes because there just aren't.
So you're gonna end up with 4 of everything.
But you're going to end up with, less
An
than,
even weighting.
yeah, because right now, like half of them are nothing.
Right. And so it keeps guessing. It guesses nothing perfectly.
Yeah. It looks a lot like, I've seen a lot of nothing. I'm guessing this is nothing.
So here's a great example of stratified sampling, right? Our sample is just one of each, not. So we're just saying, well,
Red people want to, but one for intro. Got it.
Yeah.
Okay.
It's Republicans, Democrats, and Green Party.
That's
probably what-
independence, bro.
they were getting into.
No, that's way less green.
All right. So let's try and get that. And then, wow, that is interesting.
So the array that you want to split is Y, first arc.
Okay, train.
And then number of iterations, default is 10, so you probably want to use 3 like they do.
Okay, comma and enter. 3.
Yeah, and then this is proportion, so 50% or whatever percent you want.
Comma where?
0.5.
Test size.
Oh, but we're just taking the training set though. So really we want 101. And then that'll just give us the test value should have all the data in it, right?
It's an integer. It represents the exact number of training samples. So if you want 1,000, you just put 1,000.
Number of training samples, but we don't want 1,000. We want to stratify it. We want to.
No, 1,000 is fine,
Yeah.
as
Oh.
long as
It will sample it
they're
and then pull out 1,000.
sampling evenly.
Now you want to histogram that and sort of like.
Exactly. Palms Brad.
I only had one beer, so I'm still on it.
Oops.
Oh,
Oh man, this page has a link to your pictures.
Nice. And then this one's 10, right? Same last column.
something like that, comma so much. Those are all the things.
Three.
The default is 10. We didn't want to wait around. So iter is number of reshuffling and splitting iterations. So
Not subscriptable?
Oh, this?
Wait, just scroll on a little bit. You have the NP histogram. No, I think
No,
it's
no,
the
it's
histogram
stratified
line.
shuffles.
No, it's the,
No, like
yeah,
there.
line 18, and you have it down below. The correct way
Yeah.
to call that.
I think it's void. No, it's not void.
Just scroll down 5 lines for me, please. Maybe 10.
Maybe 11.
Where in the fuck did you?
He deleted it.
You deleted the histogram that we had the other histogram?
Oh, yeah.
Yeah, of course, why would you need that?
Well, it would have been nice to have it now.
Well, but what's the line number? Oh, 18.
Numpy.
Bins
Bins.
equal.
Oh, okay.
What?
You're right. Error. That still took an extremely long amount of time.
Just to get through that.
Oh, it's because we're reading in the 25 meg file on line 15.
So it looks like
We could skip that.
it's producing a set of indices. So you see here where it says
Yeah,
over it.
see, I'm just like,
Jeez. Come on, people.
I mean, you could just print the array, like.
It's producing an array of indices that it wants you to go pick.
Good lord. Fine.
Because they're evil.
What are you supposed to do with that?
No, we have 9s and 1s in here. That should be right.
I don't know what I'm looking at.
Yeah.
But see how it's like an object? It's a shuffle split thing.
There's your problem.
Subscriptable. Ah, get it.
I get it.
So the output of it is not the input of it. You shouldn't assign train to it. You should assign
No, look,
stratified stuff.
You can't.
look, stratified shuffle split has a capital letter hit the constructor, right? It's building an object,
And that object has a property output.
which is it's an iterable object,
So you can iterate it, you just can't sub into it.
right? You have to
Yes,
like,
into it.
you have to box it in order to,
Train index and test index.
but you see how they're doing the,
Where's SSS coming from? Oh, up here.
yeah, that's what,
That is the result.
That is the
calling
result
constructor.
of stratified shuffle split.
Yeah.
You iterate over the object it gives you back, and then you can iterate into the 2 dimensions. So it's a 2-dimensional array object, X and Y, is that the deal?
yeah.
Yeah, so it's a multi-dimensional object. You iterate it and then index into it. 'Cause
Wow.
that's easy.
We're making
Yeah.
all kinds
So
of
that doesn't
progress.
sound like fun to me, really.
Yeah, I'm over it.
Yeah.
So anyway, for the next TIG, we're gonna talk about DevOps. We can just run down this whole Python thing. Okay, so that's giving you back an object, and that's what that thing is showing you, right? 2, 11, 2, dot, 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 like there's
Yeah.
dimensions on there, right?
So if we wanted to try this, why not?
Sure. Okay, bro.
You just do. That's pretty awesome, actually.
Wow.
Oh my god.
You're stuck in block select.
All right.
Just comment at 24. So it's okay.
This is on the wrong line too. Right?
24 is
Going to explore.
All right. So now we have
what?
We don't even know. We have an SSS.
We have
Stratified
train.
Shuffle split. And
our X's and Y's. Really?
train index. Train index.
All right. So we don't need this right
test
now.
index,
So let's
right?
get rid of
you're
that.
getting the train and the test out of the stratified sample. I don't know why they call it train and test, because you're only running the train data through it.
And then we need to append that onto an array then, right?
Well, it's iterating, right? It's for train index, comma, test index in SSS, right? So it's setting up train index and test index in 2 dimensions. Is that right? Correct. Under why?
Train and
Yeah, it hurts my brain too.
I don't really understand what that's doing.
Yeah, me neither.
what?
I don't know what the stratified sample shuffle split is doing.
Well, it's returning you an ituratable object of 2 dimensions, it looks like, right?
Well, every time you call get next, it gives you back a tuple with two things in it.
A tuple with 2 things in it. I get you. Okay. All right. And the 2 things that they're calling these 2 things a train and a test index, but that's just the wrong name, right? It wouldn't be a test index, would it? And then it's saying, look in your train data set by the indexer that gives you in the tuple to find the value. Oh, I see. Look in the train for both of them. And then you get Y and Y. That's
Well,
weird.
That's not what we're trying to do.
Yeah, that's weird.
Here's what we do. We do it brute force manually. What we're trying to do is get a pseudo even distribution on this set of numbers.
Yeah.
Right? So all we need to do is sort it by the last column.
Using link. Oh.
It's fine. Sort. Python sort. Right?
NumPy sort by last column.
Yeah.
Sort axis 1.
Wait, isn't it just a Python array? Can't you just sort a Python array? There's a dot sort order equals y. So a dot sort order equals whatever the last column.
I don't know. I mean, well, we want to sort by that column, right?
Yeah, the last. Yeah.
Pandas. Shout it out.
So, pandas and NumPy, like, they're the same people, right? So I'm assuming that you would do sort, and then the name of the, inside of the parameters, you need the, the column, and then axis would be 0 because that's sorting by row. So you're sorting based on that column, the row values.
Two-dimensional
Try with
array. We don't, that doesn't have pandas there.
Sorting
What am I
the
searching
individual
for?
array.
He was just saying that he's assuming that NumPy does the same thing as pandas, right?
Yeah.
Yeah. So try the arguments he was saying for that he thinks pandas see if NumPy does.
Do we have column headers? So?
We don't know. We just have an indices.
Oh,
And a NumPy array anyway. But
yeah.
Sort numpy array by column.
Correct way is quite ugly. There we go.
So
You want-
transposition, yeah, it's not what we want.
I suppose this works, 185 upvotes.
Oh, there you go. Actually, look at that. That was awesome. That was better than the answer.
Where
One
was that?
line. I suppose this works. There you go. Perfect.
Hey, what?
Taste that. That's perfect. Okay, so
That's
train,
just do that.
train, and then that one's train, and that's a 10 or a
Not
10,
10.
10, yeah. Or, sorry. This is not defined.
That's some other time.
Okay. Oh my God, this is gonna be ridiculous.
I mean, so
That seems to have worked.
it worked.
So,
So now you've sorted it, and now you want to what? Continue with your thought there, Reed. So once you sort it, then you have to pick evenly from each grouping.
Yes. So now.
we can go back to the way that we were doing our split. From
If all of our users logged off now.
No, wait,
They're
wait,
all dead. No, 6 viewers strong. I mean, I think they're asleep on YouTube. Oh, 7. Look, we just added one.
wait, what are we doing this for? No. What I wanted to do was basically pull out some elements of train. Now that we have them all sorted by their classification, I wanted to pull out a more even distribution of the values out of. So, in other words, I wanted to take all of the 9s, most of the 8s, some of the 7s, a few of the 6s. You know what I mean? Like I wanted to take basically, to 4. Let's try it just with 4. Okay, so going through the list,
Yeah.
right? And I want to take 4 of these, 4 of those, 4 of these, 4 of those, and then let's try that. But 4 is not the right number, but there's 10. Let's go with 10. Yeah, 10. Take all
You get
10.
10 of the royal
Royal
flushes, and
flushes.
that's your smallest step.
Yes, exactly.
So if you did 10 of each, you'd have
10 of each, you'd have
the same
100,
number from each one.
100 rows of training, and that would be.
What do we do for that? I don't know. I'm trying to think of like something we could search for that. Or are we just doing that manually?
Let's just do it manually. How hard can it be?
Alright.
This will be going back to our very first, times in Python. Our little exorcisms. So,
All right, so I want to start with
four.
a empty array, basically, right? But,
yes. I'm in JavaScript, man. I can't get out of JavaScript.
yeah.
I'm stuck.
What are you trying to do?
All right.
Every JavaScript developer.
Yeah. There we go.
And check.
What is going on? Oh, the
The arc sort.
arg sort.
Also, line 15 is still going here. That's 25 minutes.
Yeah, it definitely did it.
Okay. So here.
So now,
Mm,
what is our target? You know what I mean?
Well, you
Yeah,
only have 4
okay,
royal
so-
flushes, right? So you can have
10.
10. There's 10 in the train data.
Okay, so 10 of each type.
Right.
So just pull 10 of each type.
Yes. So basically, we're
Is
saying.
there a cool Python way to do that, or do you have to do the crappy way? Well, the current type is until 10, skip till
Yes.
next.
Yeah.
There's not a crappy way to do that, right? Say, current hand equal, grab the first one, keep going until you get 10 of those, then skip until the next hand, then keep going until you get 10 of those, and then skip until the next hand. That's awesome.
Total
Brute force
collected
it is.
hand count. All right. Current hand.
So we should post this onto Exorcism.
Yes, and get some
That's the
feedback.
worst
That's the worst
Python
way we
I've
can
ever
see.
Yeah. Wait, if it's less than 10. Yeah. And result dot, thank you, append, like push. No, not push.
Yeah, value. No, not value. You want to push the
The whole row.
You want to push row. That doesn't change.
But only,
Oh,
Current hand index. No,
Only changes
Yeah.
after you've gotten 10.
yeah.
Yeah. Okay.
That's the deal.
else. Just else
Total
that.
collective. Oh,
You just
else.
else that. Yeah. Else it.
Yeah.
Keep all the thing.
But you needed to add one to the total collected hand count.
Plus.
Doesn't exist in here.
What? I always spent 7 months on it.
Print result. See what we got.
Yeah, print result, which would be all the rows. It should be even distribution of rows.
But we're missing something here.
Yeah, we're not done yet. So if it's less than that, append it.
You can't increase your current hand index until after your value in the 10 is changed.
Yes, you're right. It's not just an else. It's if you were right the first time.
The value in
Wait,
the
No.
No, that's right.
That'll work.
No, that's cool.
Let's
Yeah,
try it.
Let's try it.
I don't think it's.
No.
Yeah, up here, right?
Yep,
Test is not defined.
That's later. That's your code. later.
that's,
You
yeah,
didn't
if you
reset,
just
you
print it
didn't
out.
reset
vertically.
total collected hand count to 0.
There you go.
That's yes. In the else. You have
Anything
to-
else? Yeah, current hand index and set turn, yes, that's it. 0.
Good call.
Why? Oh, because of the swing.
Let's just take that.
Okay, scroll up.
What the?
What?
I can't.
That is a. What happened to the array? You just got.
The
no,
test is not defined.
Oh, there we go.
That's weird. What are you looking for there? This would be ordered, shouldn't it? Oh no, those are the rows. Those are the hands.
Yeah.
So 0 is a. So
Yeah, sorry, print
results.
results,
Select this
10.
last column.
Yeah,
I was thinking print result.
Print result
colon, comma 10, yeah.
Nothing. 0.
Oh,
9. Is it 9?
So where's?
Yeah, 0 to 10. Yeah, 9 because you're putting the whole row in there.
no, that's right.
It's just the game code result is not a tuple.
Oh.
You did a colon.
Calling commas fine.
We do
It turned
have-
into a tuple because we're in here.
You're pushing rows.
So np dot array that. There we go. And then now I can histogram that.
Yes.
There we go. And it all comes back to the histogram.
Bins equals 0, a range of 0 to 10. What the la 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 la?
That was not what I expected. Those should all be the same number, right? You're printing the last column, which should not be 11,000.
Yeah, there we go. Pull that out of the array.
Refactor variable, bro.
Yeah, refactor variable. Why does it have 22,000?
We're appending something still probably, right?
You just you append the row as you collect them, and then, oh, but you're not,
We gotta
are
check
you
to see
skipping,
if-
you're not skipping the index. You're going +1, but it needs to be not
You're
+1.
not checking to see if the value is, you're just checking.
Right.
The hand counts less than 10.
Ah, yes, yes, so we're actually including every single one, right.
And
Yeah.
value equals.
What is that?
Current hand index.
But that's why you have to change out your else statement. This would have you increment it out. So your and actually goes as a separate if inside the top if, and you don't else off of it, right?
Yeah.
Nope, no, other way. Has to go inside.
Inside. Okay.
There we go.
76.
And
There we
6
are.
because there's not enough.
Why?
And we fell off
Should've
the end of the
worked.
Because we didn't hit 6.
Are you going back?
How
to
come we didn't
start
get
at
any
the
row
beginning again?
flushes, so.
You're not going back to the beginning of the array again, so you might very well pass by the last
That's more like it.
straight flush before you even hit it.
Wait.
No, that was
What
right.
that-
That was
yeah.
evenly distributed except for the one that only had, wait, what? That. Should have been 4 on the end across the board, right?
You gotta reset and start at the beginning of the array again.
It was sorted, right?
No, you shouldn't have restarted it or
Oh, it's
restart because we sorted it. So you should be going in order, just skipping large blocks. That should have been a 4 on the end.
Did it run another iteration of the loop, maybe?
Are you?
No.
Which row training value equals rows 10. Collected hand count is less than 4, enter here.
If you're on the same hand you were on previously added until you add 4 of them.
If I've got a matching value, add it and add the hand count.
That was totally right, except the last one doubled up. You want 9, right? He's trying to print the one that's got 8 of them in there. And he printed it back. Where's the one that gets 8? That's right.
0, 0, 0, 1, 1, 2, 2, 2, 3, 4, 4, 4, 5, 5.
Something is
You
bizarre.
missed 8s and 9s, but that looks right.
Just print them all out. We're talking about 76 rows, just print result array.
Which privilege you collect?
Wow.
Top hand is 9, right?
Oh,
Yeah.
yeah, 7, 6, 5, 4, 3, 5. That looks right.
That looks totally right.
The
What happened to the
histogram
histogram?
Yeah.
0 to 10 bins range, 0 to
0 to 10 should be 0 to 9, shouldn't it?
There you go. Because we didn't iterate 0 through 10.
oh, because the 0 hand,
Yeah.
the nothing hand.
Wait. Are there ones with 10?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Yeah, there's hands 1 through 9 and the nothing hand. So there's 10 instead of 9.
Okay.
I think there's zeros. The hand value is 0.
This might have been.
Should have been 0 through 9. I'm confused why. Look, the array here.
Well, he's
for
printed it.
bins.
Scroll down. He's printed it out below.
So if you take your count.
No, that's right. It's the histogram that was wrong. But I don't understand why switching the range from 10 to 11 fixed that. That doesn't make any sense to me.
1, 2, 3, 4, 5.
What the fuck is this? Histogram is just broken.
That must be it.
It's not us.
It's definitely not my code. It's
Well,
some
I
other
mean,
guy's
we
code.
did it right. Like, look, the actual results are correct. Okay, so regardless of what histogram prints,
We finally got it.
the results are what we wanted.
What happens if we up the total collected hand count from 4 to 10 again?
Right, now it should evenly distribute, except there's just not 10 of some hands, but that's fine.
Or as we needed.
Well, okay, yeah, it should be sorted, so it should be fine. Yeah.
That's all, hand count of 10.
Back to 10. turn.
You made it.
Okay.
You gaffed it.
Outside the
Most
field.
of it.
I actually love that.
That's the way to force it to use it.
It's a throwback.
It's not. I think I like Python. I think it's like one of the most readable.
Wait, what did you call it, Liz?
Mumps.
Oh, no, we said for that. It's a like
Throwback.
It's a throwback
throwback.
to the old mumps.
Yeah, mums. Oh, that's good stuff.
Trying to be something that I believe that it's still using mumps.
I see it.
No,
No?
what a medical device company. I feel so sorry for you guys.
Did you ask him what it was, so in case you ever get hooked up to that device, you go, no, give me a different device. They're the shit mums. Do not stick that in me.
Worried about staying as a viable company, I think, because mumps is officially pretty much dead at this point.
All right.
It's been eradicated, I think is what they're talking about. Good one. That was a good one.
That's all. I mean, so if we run this for the test, so we're not going to run
So
this.
bump the hand count up though, right? Did you
Yeah,
bump the hand count of 4 to 10, so you collect a larger sample,
On line 25.
less than 10.
Attribute has no shape. Oh. Hand count on where 25.
Okay.
If there are 10 hands of everything that we think they're supposed to be.
Okay, so we want to test that's down there. So I want to print train here, right?
Okay. What do we got?
Evenly distributed.
Stops at 7.
What did that go? 2, 3, 2? What was that up there? No, that's good.
It stopped
Oh.
at 7.
Why? Why would it do that?
Apparently we didn't have 10 hands for everything. Try 6.
That's what the histogram was saying earlier too.
And you only got 3 7s, but 10 of.
Was it this one?
Yeah.
I wonder if it's because. Wait, no, there's supposed to be an
Still
order,
stops
right?
at 7, so there's no 8 and 9. So
We're not actually sorted.
yeah, is it not actually sorted? It was sorted though.
No, you wouldn't be getting multiples of things back if it wasn't sorted.
How come we only got 3 zeros? How come we only got 3 of 0? We know there's more than 3 nothing hands.
Yeah, fair enough.
There you go.
What the hell did you just do?
He assigned the output of the sort statement to itself.
It wasn't sorting it, but this one doesn't have enough. All right, so you said 6. I thought there was only 4 9s or something.
I got 8.
4 8s, it looks like.
Yeah, so we had it down to 4, and then we got everything. All right, well, at least we have an even
And
distribution.
5 doesn't work, right?
5 doesn't work. No, that's good.
5,
Well, 5 works only because they're in 4 9s. Yeah.
That might be
That's
a good
okay.
That might be a
Yeah.
good training set.
Yeah, maybe. So let's go 6.
No, because we lose.
6 didn't work.
We lose the
Lose
9s. No, we lose the 9s.
With our algorithm,
The
we
8s
just
is
Oh,
fine,
okay.
and we lose the 9s.
That's a stretch to call that an algorithm.
Yeah. All right.
That's
That's
our
fine.
brute force loop. That's a stretch to call it an algorithm.
All right.
All right, now we better guess this crap right.
Yeah. All we're shooting is for is better than 0.59, right?
We still
This is really fun for me, by the way.
Is it?
Yeah, sorry. I feel like we're mobbing on this.
Oh.
5 3. Oh, hey,
Oh,
and even.
it's different.
Oh, we did get more data.
We got a whole lot.
The
No,
diagonal though is shit.
the diagonal is shit.
But you're really guessing the middle really well. What's up with that?
Huh?
Well, it says, half the time it's going to be in the middle. You've got an equal amount of data. Everything else can go off here.
So what we're showing is the worst poker player in the history of the world.
Yeah.
So you're saying there's a
Why-
chance.
Why did that not?
So what do we just, can we summarize, what do we just do? Did we just
No,
take?
we have no idea.
Yeah. Took something bad
Did
and
we
made it a
just
little
take
bit
that
worse.
10 of each or 4 or 5 of each?
We took
That's the training data?
up to 10 and
And we ran it against some of the test.
yeah, the thought was if we had
All of the
That's
testing.
tiny amount of training
all of the test
All
data.
of the
but
test
we were
data.
trying-
So this is
we were trying to
800,000
get
is the dark
evenly
blue.
Training data set, because it was saying, I found 50,000 nothing hands and
That's
two.
That's too small of a training data.
Yeah,
It's not
it
gonna
is,
fit.
it is. Can we
So
do
can we
this?
fix our algorithm to
Yeah,
pull
can-
maximum up and
Yeah, maximum up to a certain amount.
algorithm? Can we fix our crappy for loop to work? So grab the 10, if the total collected hands are less than, like, call it
So I mean, what do
100.
you? Well,
I'm with you on the even number of them, but it has to be a high number.
Yeah, so the problem is we only have a maximum
Yeah.
of 4 in the 9 hands.
Yeah.
Like, you will never get more than 4 royal flushes in that set, so it won't be evenly weighted, it'll be
It'll
mostly
be
evenly weighted.
More evenly weighted than it is.
I mean, Chris cringe, I assume that's mathematically a horrible thing to do or something.
No. Let's 10. Let's try it.
It would be like 100.
oh, we got to figure out what's happening here, right?
Yeah, 100.
Oh, wait.
So you'd have to, if you wanted to try and get more of different types, you'd have to, inside your loop, test for when value changed from last
Yes.
value and
Yes,
reset your
exactly.
count immediately when that happened.
All right, what am I doing?
What Bill just said.
So you have to create a local variable equal to last value should be equal to the first value, which will be 0.
So what you need is to keep track of the last value you saw. Right?
Okay.
So last value seen.
Here.
Sure.
And then we're using
So
that.
up at 24, you have to say if
And so you have to say if value, if value does not equal last value. Then increment the current hand index.
yeah, current and then you have to set your count back to 0.
It's ready for exorcism.
Yeah, it is. Now,
There's one dude that like trolls the Python exercise, he'll give you all kinds of feedback, he gives you feedback on like every single one of them. Yeah, I think his name is Scott Reed. Every single one of them.
Yeah.
All right, what do we do there?
Is YouTube gonna censor you for that? So-
Yeah, we're already in the YouTube adult channel section at this point. Doesn't much matter. That didn't work at all. We got a bunch of no
Well, we
hands.
didn't change our max count, did we? So
Yeah,
line, yeah, we went hand count.
Like 50 or 25, something.
Let's make it 100 or even 1,000.
no. 100. I like 100.
But it still should have.
Yeah, it should have worked and it wasn't working.
Yeah, it still should have gotten. It should have done what it did before.
And now, actually,
Yeah, if we have it at 100, we can't really test it. But 10.
That should
So
work.
I changed 4 to 10 last time. That's what.
Yeah, it should have. It should have produced the same output with 4 9s.
Won't this
6
keep
8s.
skipping them?
so
We have
we
to
actually don't
say-
need
You have to,
line 30 anymore.
yes, we still need line 30.
The first value is going to be a 0.
Yeah, in
We're
fact,
not,
we can do
the
it
problem is
right?
we're not resetting current hand that index. No, we.
Wait.
No, I think
The
if we
very-
just stay this and here, and we just append, we can get rid of all this other stuff, right?
Wait,
We're just incrementing which one we're on.
Right.
If that is less than 10, we're shoving it in, and then we're just ignoring the rest, right?
isn't the first line?
I think we
not
can simplify this algorithm. We can do a little exorcism stuff on it.
gonna work?
right?
Isn't the first line not going to work though because last value is
What's
initialized to
define
0.
first line? Give me a line
Sorry,
number.
Line, I couldn't see your stand. Wait, line 25. I thought last value is initialized to 0, and the first value you pull out is a 0.
Yeah.
So
it
That,
will
it would skip over that.
skip over
skips over
that.
And then if total collected hand count is less than 10, we should just shove it in there.
Just
So
a match.
Don't get rid of line 30, I think. Yeah? We all
I
concur?
don't know yet, but you're saying just append the
Comment
row.
out for right now.
Just append the row and collect the
And
hand, mark the hand.
And then
flag.
you can also get rid of the else.
There we go.
Yeah, 33 through 35. Yep.
Mm.
And then, there you go. I love it.
Well, excited.
Luckily, I couldn't see that on the YouTube channel.
This is why we need this Big Brother style videoing concept. We're gonna start a reality TV show and just put webcams. It's
Yeah.
watch us program. People will pay millions. We're gonna stream it on Twitch. There you go. Now crank it up to
There
100.
we go.
Still a crappy guesser.
But, yeah, no.
We're not guessing the zeros a lot more frequently.
Okay, and now, we gotta get above 5.6. Come on, get off 5.6.
No.
They won't.
4.2.
I don't think a smaller sample is ever gonna be better than a full sample. Is it? You can only get worse.
That's not necessarily true. There's the idea of normalization and overfitting. So I think I talked about overfitting before. If you have a lot of
Well, yeah,
data.
small sample would, oh no.
Yeah, so the idea of overfitting is that you get too close to the actual, like predicting the same thing every time for the samples that you've seen. And so 5.5.
Same thing.
Although in poker, only so many.
Man, this is a hard.
It's hard, yeah. So wait, what you just said is kind of interesting. Overfitting this data set would say I'm too close to guessing the same thing every single time because I've seen so much of one thing, which is kind of what we're seeing here, right? We've seen the no hands so many times and we
yeah.
haven't seen enough variation.
As you go up,
They're all unique hands though,
Well, there's 9 possible, 10 possible, well, no hand and 9 possible hands or whatever, right?
right? Yeah, it's all unique combinations of.
Yeah.
Well, we haven't tried changing our classifier either.
What happened to your diagram? Your diagram
Right.
never came up on that one. Where is that? Where's
I
our?
think it's
Oh, so
still- it's still
one
crunching it
interesting thing is,
and we're shrinking down closer and closer to the lower end
It's crap.
because we're getting
Total crap.
we don't have enough instances of the.
Oh,
complex.
yeah, so actually, we don't actually see what's going on because this number is so big.
yeah.
So that's probably what's happening right now.
Yeah. Let's do that same thing against the test data.
We need a data
Let's
set.
do the same
Sample, just sample the test data.
Yeah,
Exactly the
yeah.
same way.
Right.
We're gonna loop a million times here.
Yes.
Okay.
Python, bro, you're fine. You're fine.
There might be some functional programming concept that we need to learn here.
Oh, we're supposed to say.
What a factory.
He said softly.
So then the YouTube doesn't hear.
Well, that wasn't so good.
Worse than this.
So I did get the
That's terrible.
train test split thing to work.
Worse than guessing.
Oh, that's true.
It wasn't that hard.
10 possible hands.
AUC, the worst
Problem is
value
you're
you can get.
50% if you just guess all no hands because that's 50%.
I think
of the
you're
results.
guessing. I think what AUC is saying right now is you basically.
No, there's 10 possible choices here, so you could get a 0.1. If random guess would give you 0.1.
Right.
Yeah,
So,
so
it's
that's
better
better
than
than guessing.
It's better
Yeah.
than guessing.
Better
But
than
pretty
guessing.
bad. So, but if
But
you
the
change-
reason it does so much better when you have a large data set of bad hands is the majority of your hands are bad. They don't have any value.
Yeah.
So therefore, it just keeps guessing bad hand and
It just happens.
more
You're right.
happens to be
Yeah,
right
yeah.
50% of the time. But yeah.
Hey,
That looks more like
that looks more like that's
It's
good.
better. It's better.
That confusion matrix, which was what we were trying to improve in the beginning, looks a lot better. Yeah.
the ability for it to guess.
So your
And
diagonal.
we're saying it's bad because we have those holes in there, right? Those white spots and light blue
Oh.
spots, or like we guess
Well,
wrong.
No, it's the right hand side.
And the right hand side. So, that's stopped out. So what if you change it up?
You need a
SVC?
diagonal all the way across.
What if you change it up SVC to something now? So your random forest or something, or whichever one we think might be better.
All right.
Linear, we thought, my guess was linear would have been better.
Well, we could do a linear.
Oh, we can do SVC with a linear.
Yeah. There's also a linear SVC that you can do. There are a number of them we can try. Cool, guys.
So what's interesting is that the stratified sampling thing that I
Yeah,
got
it's
to
a little
work
better.
doesn't actually work on it because there's too few flushes. Right.
Oh, really?
Yeah, so it runs if you don't ask it to stratify.
A little bit better.
If you don't ask it to stratify, it runs fine and splits up the set. But if you do stratify, it complains that it only sampled one flush.
Don't you have to do it? Oh, is that what it is?
No, it's not. This is another model, actually. This is another one.
It's not an SVC with a linear algorithm.
It's linear regression. It's an SVC using linear kernel, but given the linear kernel options parameters instead of the other. Oh, ooh.
Wow. Wait a minute, that was ugly, but look at the AUC, it was actually not bad.
Is it always guessing?
0.5 is guessing.
No,
No.
0.1
Yes.
in this case is guessing.
No, 0.5 is guessing. In AUC, 0.5 is guessing. 0.3, what we got before, was like you were picking more wrong.
No, 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 no,
Then
no,
a
no, no,
random
no,
You
no.
have 10 chances.
You have 10 chances.
Yeah.
100 chances.
Oh yeah, yeah.
Guessing would be
0.9,
0.1.
0.1.
Guesses,
Yeah.
0.1.
So,
No, that's just for the first column because we're saying. So our AUC number is bad here because we're
Guessing
saying
across all columns.
our label is we're only guessing for the one index label. So it's like we can only see the AUC for the prediction of a no hand. And so that number was the AUC for a one pair.
oh, I see. I see.
Oh, well, that's pretty crap then. It should be able to guess those perfectly because there's so many options of those, right? Like no hand and one pair are the two most common.
So now we're in no hand, which is the 0.48. But it didn't guess no hand at all. It just
Because so none of the ones that saw were no hand in that row.
killed us. Yeah, but that was a linear SVC.
Wait a minute. Okay, sorry, that was my misunderstanding.
Okay, so put it back to SVC and change the label to the royal flush. How often do we guess that? That should be way higher then, right?
Not necessarily.
Chances are you're not gonna hit that in the test table.
No,
So it'll guess that we won't hit it. So it should be 100% right.
98%.
Yeah. 98%.
The sorting.
Suspense is killing. It's still crap.
0.47.
I'm very.
Yeah, but this is based off of,
1,000.
right, we have to up our training data.
But we still guaranteed that our training data had royal flushes in it, right?
Yeah,
So it does know what one is.
I mean,
that
we
means
can,
it's gonna guess
we
it
can,
more.
we can increment that number to, you know, that, this is basically what we wanted for stratified sampling, right? We put Chris to sleep, that's a bad sign. When you put your own,
Nan.
Oh, man, well, that's worse than guessing a man. I refuse to guess. What's your guess? A. No, that's not even a valid.
that's in the Big Short.
Yeah.
It's like 2 + 2 equals fish.
Nice.
Instead, it makes no sense. Like 2 + 2 equals fish.
5-2.
Yay!
We're back to where we were.
We can do it. Wait, how did you change?
Well, now we're at 9. This is the royal flush.
Are we
We're
nine?
still,
Right, so what you just did guess, so should it guess better on a no hand, on a 0? Because it knows that better than anything?
I really want to throw a neural network at this.
I know you do. Well, let's just get TensorFlow
well,
going.
I mean, come on.
Yeah,
Pick one out.
We've got 20 minutes. 10 minutes when you're at the.
they do have TensorFlow. They have skFlow, which is TensorFlow for sklearn. But I don't know if this is actually gonna try it.
How much are we going to pay Google to run this TensorFlow there?
I can run it locally. Who knows how? All right. So actually, what I
You
need:
need Python. You need
load iris, skFlow.
Does PyCharm actually hit that thing for you if we can't find it?
Yeah, it should. Actually, TensorFlow classifier.
Use that.
Why do you need to tell it how many classes you have? That's weird.
Was that why our data was so bad? I mean, like maybe SVC is the same way. What if we told SVC how many classes we had?
I don't know.
Did that seriously just, install package failed? Did that just do the right thing?
It's exciting stuff. I'm excited too.
And that goes that I hate you. So,
Yeah, you heard that?
yeah, I hate you. Like a dance.
Pip. Was it interpreter?
Just CMD that thing,
Let's do it here.
Confusion shell.
Yeah, there you go.
I don't.
It's not. It's,
Nothing to show.
no. Terminal right there. You don't even believe my terminal.
What? What are you talking about?
You get like a, I don't know, like, you know,
A REPL?
yeah, you get like just a shell right in there somehow. Window shell or whatever terminal or CMD. There you go. Oh my goodness.
Wow.
If install SK flow, well, you have to. So.
Which version of Python am I installing here?
Probably like seven.
Yeah,
Only
good
if you
question.
read
Yeah.
the-
Failed building wheel for sklearn.
You must have what?
You're running version pip blah blah
Nice.
blah, but versions available. You should consider updating the Python pip install.
Well, that was worth it. So, anyways,
Do you have an Anaconda?
What?
Do you have an Anaconda installed?
Yes.
Yeah,
you
those
use
are
Conda
Anaconda.
install.
Conda install?
Yeah,
I need to switch the
Conda
project.
if they have the package.
I need to switch my interpreter.
351 is Anaconda, isn't it?
Let me try this real quick.
Boom. Done. No. No module name TensorFlow. I think it depends on TensorFlow,
Yeah, it needs to be there.
which has a Python version.
It should have, yeah.
Or
Deep dream visual hallucinations.
I mean,
what are we getting into? I don't even know what we're doing now. It's like coding for like babies. Just type some words and press Alt Enter. It'll work. It's fine.
No.
Yeah. Because you can't Anaconda that guy. Maybe you gotta switch your runtime again. Nothing to show. Minutes here. Move on.
Brutal. All right.
Start the shot.
Let's-
So, what did we learn today, class? Yeah, that's a very good question.
Stratified sampling is hard.
Yeah, we got stratified sampling down.
I don't think
We
you
nailed
did.
that. We rocked that thing.
I don't think you did.
Yeah, we did.
No.
We did.
So something I was reading about stratified sampling said that it keeps the distribution of the original.
Right, which is not what we wanted. We
Yeah.
wanted a modified stratified sampling.
Modified.
Modifier stratified. Where we kept all that we could of the less. Class weighting. We have to modify that.
I think we should try ADA boosting.
Of course.
Yeah, that's what I would do.
Yeah, that was my next thing I was gonna say. I was going to bring ADA. Probably not. I would do it. Ensemble. Finally, we finally reached it. And we are down to 4 YouTube viewers. Including us too. We are down to 2 people still watching this. I'm still of the opinion I should write a Chrome extension that goes and searches YouTube for all videos that have 0 views and puts them in my playlist. It'll be every single TIG recording. And then a bunch of random crap. These are the videos nobody's watched. That'll be some good stuff. All right, well, that's fine.
We done then? So
I think so.
is not defined. How?
Import's failing, I think, right?
Yeah, I didn't have the import apparently.
Wow.
What's up?
Our views are kind of like in line with our attendance. It's like,
Well,
Yeah.
there's that.
3 to 5.
All right, so we tried.
This
So,
data set sucks.
That's why my PhD is getting rejected.
Yeah, it's really,
Do not use this data set.
yeah.
well, that's, I mean, so
Maybe it's so hard that if you solve it, it's the key to the universe.
But it doesn't make any sense because if you simply sorted we know as humans that the order of the cards in your hand does not matter.
Your order doesn't matter.
And if you
Right.
sorted it such that it's lower to higher, I wonder if that would help the classification.
it possibly could.
Yeah.
Oh, that data set.
Oh,
doesn't
you
do that?
sort all the other features?
I'm
So it
saying
says this
all
is
of
a
the
royal
cards-
flush and you sort the cards
would
so they're in
definitely
numeric
know.
order,
Yeah, exactly.
but they're not right now.
No, they're not. They're in
Because
random order.
because it doesn't matter for the hand, but if you
Yeah.
sorted all, interesting,
Yeah, that's,
interesting.
should do that.
what do you?
I mean, we could do that with another sort. While we're going through the list.
We're so good at writing
Yeah,
sorts.
I mean, like, while we're going through the list, we might as well sort it, you know?
So basically, we went through 7 months of Python and 3 months of machine learning Python just to learn how to write sort.
What did you put for your
Because we could've
AOC
learned that on
positive
day
label?
I'm pretty sure like,
Hmm?
Well,
What's
I
the
thought
language
for your
do? I don't know how
positive
you write
label
sort.
on your
well,
AOC.
we've done some pretty
Your
complicated
ROC curve.
sorts.
9.
hey, 71.
Holy mother, what happened?
Where's our diagram? Where's our
I think
computer?
he posts the.
That was the best we've seen.
Yeah.
Oh, that doesn't work out.
So 9 would be a royal flush, right?
Yeah, we were predicting royal flushes almost. Well,
Almost well.
Hey,
Okay.
good enough to bet in Vegas.
What
Uh,
goes
You should
okay.
predict him way better than
And,
that.
and so,
If you're staring at them, yes.
Not
Good
even
point.
saying
If I had
that.
them in my hand, I'm pretty sure you'd better than
I could predict better than that without even
I
seeing
can get
your
like
hand.
100% accuracy, I'm that good.
Pretty sure.
Yeah, you'd actually be an idiot if you bet 25% of the time.
All right,
somebody had a
guys.
royal flush.
Without even seeing their cards.
Yeah. Hey, what do you 4 people have a royal flush? I bet you do. No, absolutely not.
I'm trashing this project now with stuff for my thesis just for fun. Let's see here. Multi-layer perceptrons, a neural network.
Holy mother.
What the hell was it? Well, don't forget about the binary particle swarm, man. We gotta throw that in there too.
Differential evolution binary particle swarm optimization.
At some point, the cards are just going to get up and walk away because they've evolved so far.
Did I just? Where is the? I'm confused now.
This is by far the most confusing tape track we've ever done.
Yes.
I mostly have no idea what's going on.
But very cool.
I guess.
Thank you for saying it was very cool.
No,
I really
if this
appreciate
is cool
it.
or not. I don't even. Well, all I know is that the computer doesn't know what a royal flush is and hit him in the face. That's all I've learned so far.
But I think if we were to sort the hands, that would.
I agree, I think that would.
Isn't there? So that's just. So
No,
each
it's
row.
a complicated sort because you have to group, because it's suit card, suit card, suit card, suit card. And you have to basically take these pairs and sort them.
So the key
No.
to the actual stratified sampling was D is the data part, and then T is just the last column. So those are the two arrays. You gotta split up the data.
We couldn't even do that from that
This
data
is a
set.
tra-
though. That's the
proper
problem.
view.
That data set doesn't
Oh,
have.
come on.
I don't think we can extrapolate that data set to actually decide winning hands or not. Like, would we be?
Okay.
Oh,
Winning hands, right?
Sandy.
wait. I have a thought. Before, 2 meetings ago, shuffling did actually have an effect on the algorithm. And right now,
We're not.
since we've done our sorting and our pseudo stratification,
We should shuffle.
we should shuffle.
Shuffle this.
Yeah, after we've sorted and after we've stratified, then we need to
Make
shuffle.
All right.
Make sure you
Do we still
flush.
have our?
We can even do it inside a
Here,
sample.
go over to
Flush
GitHub
first.
real quick.
No, at the very end.
Make sure
where
you
I
can flush.
Yeah.
Where are we
Yeah,
going
flush
to go?
twice.
Look for this poker-learn.
Well, actually, you
Not
flush
what we're
once
doing
in
right
the
now.
US and flush once in Australia, so they cancel each other out.
One for the remainder.
We got GitHub.
First, let's learn how to play poker, so we know what we're doing.
There you go.
Is it?
Yeah. Scroll down to the README a little.
Oh, well, there's the answer.
No, this is not the answer. This is the answer to Ike's idea. So this guy is actually does the concept we thought we were going to do, which is that
Winning
this is a simulated game, right?
Texas Hold'em.
No limit Texas Hold'em. What's his win percentage?
I don't know.
35.
The set of all possible raises is reduced to a smaller set.
So wait, isn't dot shuffle one line? Can we just try it real fast? Just to placate Scott, otherwise I'll hear about it for a month. Shut up. I better be shuffling.
That's really true.
Yeah, exactly. After sampling. you
On a random Thursday.
shuffle.
You know what we should have done?
Oh, I just got
Sure,
79.
What? On what?
SVC.
You got what?
79 AUC.
Guess
Oh,
which
the-
hand?
Guessing flushes.
The POS flushes.
Nope,
What just happened?
you wrote something. NumPy ND array doesn't have a shuffle. Put a shuffle on.
Actually, I had it over here. Let me delete these.
Random dot shuffle. Oh, ND array have shuffle. ND array of.
No, that's not right either.
No, you screwed up an import. No, you just screwed up an import.
Yeah, that was right, actually.
You deleted stuff, but you screwed up the import. Oh. You deleted that.
Something was wrong. You get nothing out, I think.
Oh, shuffle isn't returning anything. You have to return the.
Yeah,
original, right?
yeah, I think you're right. Well, but it's doing something. Okay, yeah. So, yeah, shuffle it in and return it. Yeah. Cool. This is gonna be awesome.
22%. And we
All right, well, that run, let's go back to the GitHub again.
Wait, what were we before doing this? Okay, we just need to
50
like take
something.
out.
71%.
Well, what was it though? The last one that we ran?
71.
I want to try
Okay,
it, like
take it
comment it
back.
out, comment it in.
Scroll down, there's this graph. Look at that graph.
Worth it.
Player bankroll versus hands play, so you can see that green is winning and then driving those guys into bankruptcy.
What is green in this?
Green is one of the players, player 2.
Yeah, but is it like player 2 a different
Player 2 is
classifier?
different.
type?
Human and
Yeah, player 2 is a human.
When does alpha go?
You guys can kiss linear algorithm my butt.
Bring all your fancy machines. Well, that's looking
that
here.
actually was
What was your AOC?
got two blue squares.
It's about the same.
Okay, so wait, comment out the line elsewhere one time.
Coming out the shuffle.
Yeah, shuffle. So 5, 2, 2 versus
Holy moly. Something's still running over here.
5, 2, 2. Well, at least I won't hear about it. for months.
Yeah.
He's not gonna say it. Better be
Okay.
sure.
So
All right.
All right, let's go.
That's good.
So that was fun.
We can switch to a different data set before we go to the next one. One with more.
Yeah.
people.
So we thought that we were going to be able to use this data set to do a whole poker simulation. That doesn't seem to work. I don't know how much longer we want to keep carrying this topic based on the.
Oh yeah,
lack
I mean
of
we
attendees.
can just hit the. We can talk about it by the next time we come, but I don't know. I mean, are we reading the last 2 chapters or whatever?
You might, I mean, we might as well.
yeah, I
Might as
think so.
well. We'll do. I mean, we have to do one more because we're going to wrap up with the Talk Python TV episode. We're going to have Michael
Yeah.
Kennedy call in, and we want to, whatever. So we'll advertise next month's meeting a little bit more to get all the people back from the original meeting, so they can say what they've learned over 8 months of Python.
Not
Yeah.
to come to the meetings anymore.
Yeah.
Yeah,
So
they learned not to. Yeah.
They didn't even need machine learning in order to do that.
No, it's easy. I'll put a carrot out there and say like we'll give away a free subscription to Kennedy's Python classes or something. That'll get a bunch of people to come. So yeah, let's do one more meeting. Read the last 2 chapters.
And it's not the last 2, actually. There are 3 left, right?
Yes.
Read
So
as much as you can.
read as much as you can.
No one's gonna read anything anyways. So it doesn't matter. Read as much as you want to.
Read to the end of the
book. we'll be here next month, and we wanted to have a contest, but I don't know, maybe we
Well,
failed at
Let's,
that.
I won.
put it on chat on
I got a 79.
Right?
Meetup, yeah, meetup.
Meetup.
Yeah, just post on Meetup, and I don't know, if someone comes up with a good, if we want to do March Madness brackets, maybe that's more relevant.
Yeah.
March Madness bracket, yeah.
Maybe we can get
It
data.
might be,
Is there a way to
it might
do
be
like
hard to do.
Baseball or
Yeah, horse
There's one
racing
in-
has been a really easy to subject to machine learning, I guess.
There's one in Keto about
Yeah.
the Titanic who survives the most based on like characteristics of the passenger. So you can try to determine which one will be more likely to survive.
Sociopathy, 1. Psychopathy, 1.
Buoyancy in water, that's probably the most important indicator of whether you survive.
Yeah, layers of
Gender.
fat protecting the cold.
Ability to swim.
ability to get on the lifeboat?
Yeah, ability to shoot other people so you can
Okay.
get on the lifeboat.
So,
So we'll chat on Meetup, we'll come up with something there. Next month will be the last Python data science and last Python together.
okay, sounds
We
good.
posted earlier, we'll do a wrap up, talk Python, and then we'll call back in the beginning.
Yeah.
Hopefully we're in sometime.
If no one picks a data set, we'll just talk about it.
We'll just roll with it and then we'll announce the next track next month.
We didn't really talk about the book at all today.
Wow,
That's okay.
I mean, that was bad. so.
Next time.
All right, cool,
We'll finish
thanks
it.
everybody on YouTube for joining us.
Thank you, thank
See
you.
you next month.
Good night.
Good night.